Alright, Bio20s, I suppose you want to get started here. So we are going to finish up our discussion on cycles, talking about the nitrogen cycle and the phosphorus cycle. So, looking at the nitrogen cycle, once again we're going to move from organic forms to inorganic forms, just like the carbon cycle. So inorganic forms and organic forms being cycled throughout the soil as well as the atmosphere. So we're going to move between the two there, okay? So looking at this cycle, let's start off with the nitrogen in the atmosphere. Okay, this is probably the nitrogen you're most familiar with. Nitrogen in the atmosphere, in the form of N2, makes up the vast majority of our atmosphere. But here's the thing, plants need it, we need it, but we can't use it. It's just there, right? N2 gas is not something that we can readily use. Plants can't use it, we can't use it. We need to first fix it. So it's done by very special bacteria. They're called nitrifying or nitrogen fixing bacteria. So nitrification is the process of these bacteria converting the atmospheric nitrogen into nitrates, NO3, and nitrites, NO2. Now, in terms of what the plant likes, plants really like nitrates. They like nitrates, not as much as nitrates. They can also use ammonia if they need to. All of these compounds obviously contain nitrogen, right? So now what's going to happen is the plants take in the nitrates and nitrates. It's found within the proteins. Animals eat the plants. We now find nitrogen in the animal proteins, and that's how we get our nitrogen into our body, by either eating plants or eating something that has eaten the plants, an animal. So these bacteria are essential, right? They're essential to fix nitrogen and make it into a usable form that we as humans can use. Now, when we go to the bathroom, when other organisms go to the bathroom, it breaks down to a form of nitrogen called ammonia, NH3. Anybody that has a cat knows exactly what I'm talking about. Litter boxes, cat urine breaks down into ammonia very quick, smells quite nasty. But those same bacteria can reconvert that nitrogen back into nitrates that the plants can use. So that's kind of where this cycle comes in, right? So we have very special bacteria converting atmospheric nitrogen and ammonia back into nitrates and nitrates that plants can use, and then by byproduct animals can use. Here's the thing though, over here we have a process, let's go here, process right here, it's called denitrification. This is done by a different set of bacteria, which will actually take the nitrogen in the soil, so we'll take the nitrates and nitrites and convert it back into atmospheric nitrogen. So we can actually take that nitrogen already in the soil, convert it back to atmospheric nitrogen. This is called denitrification. Now, you may have seen this done where people will aerate their lawn. So they'll take a machine and they'll punch little holes into the grass essentially and get those little dirt pellets. There's a reason you would aerate your lawn, because the bacteria that is nitrogen fixing, they like oxygen. They're good with oxygen. It's an oxygenated process, because you'll see they're essentially ripping apart an N2 and sticking oxygen onto it. The denitrifying bacteria, on the other hand, don't need oxygen. So by aerating your lawn, you're keeping oxygen in the soil to make sure nitrification occurs. If your lawn's not getting enough oxygen, denitrification will occur, where that bacteria will actually convert it back to atmospheric nitrogen. Also, if you have poor soil, you might lose nitrates and nitrites through leaching. Now, that nitrogen fixing bacteria, usually it comes in a couple of, or the nitrogen fixation comes in a couple of forms. The bacteria, which I discussed, and lightning, funny enough. So lightning can actually take atmospheric nitrogen and convert it into nitrates or nitrates. Unfortunately, we haven't found a way to harness lightning just yet. So our main kind of tool here is the nitrogen fixing bacteria. They usually form a symbiotic relationship with the root nodules. So they'll live on the root nodules of a plant. They get a home, they get nutrients, and by part, the plant will also get nutrients as well because of the nitrogen that it's fixing. Denitrification, like I told you, this is done by a different set of bacteria. They're anaerobic bacteria, meaning they don't need oxygen, and they're going to convert those nitrates to nitrites and then eventually back into nitrogen gas. So in low oxygen environments, you're going to have a lot of denitrification and usually not a lot of healthy plants. Okay, on to the phosphorus cycle. The phosphorus cycle has a abiotic component and a biotic component. It has a short-term component and a long-term component. It's also the only cycle that does not have a gas state. So there's no phosphorus gas state. All the other cycles have a gas state. This cycle does not. We have phosphorus in the biological short-term. We also have phosphorus in the geochemical long-term. Phosphorus can also be stored in the bedrock or the soil in the form of phosphate ions. So PO4, 3-. So let's take a little look at the phosphorus cycle here. I like to start off with the biological cycle. So in black, that's short term. Red is going to be long term. So I'll just write that on the board for you here. So black is sorry, I messed that up. Whoops. Black is our short-term cycle. Short-term cycle. There we go. So we have phosphorus, right? In the soil, in the rivers. It is dissolved in there. The phosphates are taken up by plants. Plants decompose. Decomposers return the phosphorus to the soil. Plants take up phosphorus, decompose, decomposers return it to the soil. Very basic. Animals eat the plants. Animals also decompose, return the phosphorus to the soil. So this is a basic biological cycle within a food web. In terms of the long term, geochemical cycle, some of that phosphorus can make its way into oceans through runoff. Some of that phosphorus stored in bones, teeth, and waste will find its way into the ocean, and then over time, that phosphorus is built upon by sediment. So it's stuck at the bottom. So it's just built up over time. But eventually, through geological uplift, when all that sediment is piled on top of each other, eventually it's brought up through the process of making land masses, mountains, different things like that. Sometimes the water levels will change, but all that phosphorus that's stored in ocean sediments will then be uplifted, and now it's stored in the rock. And what happens is, as the wind and the rain and various things kind of chip away at that rock, it's then weathered to return that phosphate back to the soil into the river. So a phosphate ion, so phosphorus, can be present in a short-term biological cycle or a much longer-term cycle, which takes thousands of years versus a couple of years there. So you can see which cycle the phosphorus would be a part of. So that's the nitrogen cycle and the phosphorus cycle, and that's about it for cycles. So thanks again for watching. We'll chat soon.